majority of the students have participated. And well, the results, as you are coming to see, it has a lot to see. First, let me advise you, because this is a general problem that has to do with students that are participating or enroll into online or digital learning programs. Being that they are not in physical contact with their lecturers, they are not physically present in the class, they took that for granted and become very, very lazy. In fact, sometimes some of the students don't think and behave as students. Being that they are taking lectures, they are taking their tests and assignment at the comfort of their home or working place, they assume they are not 100% students. This contributed a lot to the failure, difficulties, and the worst situation that some of you are finding themselves. You are a student, you are not different from students in campus. The way we are lecturing them is the same way we are lecturing you. The same way we are assessing them is the same thing we are doing. Well, only difference is your only class. It's the same certificate. The certificate of students that are in campus is the same certificate that shows that you have done your classes or your lectures or your program online. So if that is the case, you should also behave and conduct yourself in the same manner as if you are in the class. If you are in campus, if you are going to the lecture, you prepare yourself. You bath, take your lecture materials, you go to the class in time, get a seat, and then wait for the lecturer to come. When the lecturer comes, you jot, you write, and you ask questions. The same thing also here. There's no any difference. It's not different at all. So if we didn't change our attitudes towards our program, it's going to be mere waste of time. We are going to waste your time, we are going to waste your resources. So it's better to adjust, because the way and the manner I'm seeing some of you are writing, are responding, are presenting their issues in our WhatsApp platform is very, very unethical. Some are just talking anyhow, as if they are in the market square, saying anything. Don't forget, we're in tertiary institutions. We should be mindful of our tongues, the way and the manner we talk, the way and the manner we present our cases. Somebody was asking, how can somebody answer questions, calculations in 10 minutes? This one, we are never even taught. Look at, you are in tertiary institution and you're talking like this. We are just lecturers. We are not to teach you. We are just to guide you. You have to go and do the extra work. You have to go and get materials. We have a library, virtual library in your LMS. Go and consult textbooks there. We are only to highlight. We are just highlighting. But it's you that are going and do the rudiments. Our own job is just 30%. Whereas your own what is 70. That is why when you score 70, we say you score A. That you have done all your parts. The 30 is not your part, it's our own part. Nobody is asking you to do that. And then somebody is saying, we've never been taught. Don't ever expect you are going to be taught or you are going to be teach everything here. But we have also the right and the privileges and the space to ask you any question you wanted to ask, in as much as we have done the topic. That is tertiary, that is what's called lecturing. It's not teaching. We are not teaching you. We are lecturing you. So you should be mindful of that. We should be mindful of that. I have the right to ask you anything. Anything. In as much as I mention it. If as much as I say there is a interquarter range, which I believe I have done it. We have done it in what? In major variability. And then the issue of calculations. All those calculations, see, before we issue questions to you, we have to solve the questions with respect to the timing. And that particular, those questions I gave you, you can answer them all in 5 minutes. Because some, they doesn't require any 1 minute or sorry, 1 second thinking. They are direct questions. Even the calculation, you don't need even to go and put calculator. All the questions are very straightforward. You can add 5 plus 7, 12, 7 plus 8, 20, 20 plus 9, 29 plus 10, 39. You are asked to calculate the mean divided by 5 is going to be what? 7.8. Then, do I need to calculate? I don't need calculate. We are giving a set of parameters and you are asked to calculate the mode. 3 is the answer. It appears 2 times. How many seconds is it going to take you to answer this one? The extra time you gather from this kind of question, you go and do the calculation if there is anyone. Even the group one, we say what is the mode? Is what? 10 to 15 because it's the one that has the highest number of frequency. What is the calculation there? That shows we are not doing the right things. That is why we are finding it difficult. He who failed to plan is planning to fail. Most of us are not planning. Somebody is saying is from work. Do you think if I'm going to be entertaining all your excuses, I'm going to exhaust just excuses? Everybody will come with his own excuse because everybody has a problem here and there. That is why at the beginning of the class, we set what? Standard. We set our rules and regulations. We explain to you. We are going to be having tests on Friday, 9 to 10. And it's going to be 10 minutes. So if you didn't participate in the test, that is not our own problem. Because it has been already established that every Friday it's you that you are going to make availability of what? Time for you to participate. You sign in, the system lock you out. That is not my own problem. We say you should make what? Provision of strong what? Internet services. Because if your internet is not strong, definitely you are going to be locked out at a certain particular point. So what do you want me to do? I can't do anything because that is not my own case. It's you that you ought to provide enough service, enough internet service. If that is not the issue, then try to sort out with your colleagues. Your colleagues are there. Let them tell you what is happening. Because the way our interface in the LMS is not the same thing with your own. What we are seeing is not what you people are seeing in your LMS. What you are seeing, it's not what I'm seeing in the LMS. The tutors LMS interface is different from student interface. So I can't sort out. I don't know what you are seeing. And moreover, that is not my area. It's the area of the technical team for their digital learning, DLC. So don't stop asking me, you have this one, you have this one, you have this one. We need to articulate ourselves if we are really serious, we wanted to pass the course, wanted to excel in our studies, in our career. Because the way and the manner we're handling the program is what is causing all this problem to you. Some of you didn't take it serious because you are not attending any physical class. You are not seeing the lecturer physically. You are not seeing the blackboard physically. And so they'll be thinking that this is a normal. I saw somebody saying this digital learning, wow, it's going to be wow forever. You know, as much as you don't do the right thing, that is how we are continuing saying things. Man is the architect of whatever befall on him. Whatever you see is the consequence of your actions or inactions. If you pass, it's you. If you fail, it's you. Don't ascribe it to anybody. Because you are the one that design. You plan and design that failure through your attitude. So please, especially in the other group, I don't want to start responding to some way and the manner some of us are presenting their case there. So we should adjust ourselves. Nobody is saying you should not complain, but you shouldn't be putting it in a very informal way. Now, our thesis, sorry, our assignment, I've not marked anyone. I'm just compiling them. So I'll take time when we're done with which this one is going to be the last topic for descriptive statistics. So after the assignment for this one, I will now sit down and mark the entire assignment for descriptive statistics. So this week assignment is going to be two. One for measure of variability, that is measure of dispersions, and then the data presentations. So thank you very much. Let's go into the lecture proper. I don't know, I block my camera.
All right, sir. Let me adjust the setting.
Okay. So once again, good afternoon. As I see it in my pre-lecture talks, this is the last part of descriptive statistics. I believe my brothers and sisters, they can recall, we say statistics is divided into two. We have the descriptive statistics and we have the inferential statistics. So today, we're going into the last study sessions, 5 data presentations. We have seen so far. We have discussed what is biostatistics, what is statistics. We have seen the scale of measurements, and then we went ahead and discussed the issue of locations or measurement of locations. And then last class, we discussed measurement of dispersions. So what next? So after collecting and organizing data, all these processes we're discussing is the issue of what? We have already collected our data. The next crucial step is to present it in a clear, precise, and meaningful way. It's like when you have collected drugs from the pharmacy, you have a shape, or maybe, yeah, let's say you collected drugs from the supplier. Now you are coming to what? Sort these particular drugs according to their usage. That is, these drugs are for asthma. These drugs are, you keep them in one place. You now take those for HIV. You take those for blood pressure. So what you are doing that, you are organizing the data. So the next thing, the same thing here. Effective data presentations allow for easy understanding of the data's characteristics and patterns. Okay, because the way people say it, seeing is believing. When you see something, you get to understand it more. So by mere just looking at the figures, and you cannot be able to do the standard deviations, variance, and what have you. You cannot be able to understand what the data is saying. But if you can present it in a what? In pictorial form, okay, in visual format, you will find that you can easily understand that this data is the mode because it's the highest in terms of maybe in the bar chart or in the histogram or in the pie chart, because it's having the highest percentage. So this is what we are going to look at in these lectures today, the various graphical and tabular methods used for presenting data. The first one is the tabular presentations. A table is a schematic arrangement of data in rows and columns. It is a simple yet powerful way to summarize data. So if you know table, I don't need to go too much. You know, data is what? Sorry, tabular, our table is a way in which we arrange data in columns and in rows. Let's look at this particular table. Do we have different types of table? So you can see this is a table. Okay, this is a table. Here, anything here is what is called the column. So you can see we have how many columns? We have 1, 2, 3, 4, 5, 6, 7. So we have 7 columns in this table. Sorry, we have, I counted rows. We have 2 columns, the age and the frequency. Then we have 7 rows because anything here, okay, look at this, is a row. That is a row. But anything here is column. This is column. So we have 2 columns, 7 rows. Then this is table that you are seeing is a typical example of frequency distribution table. This style of table shows how often values or range of values appears in the data set. Because you know frequency is telling you that how many times a certain particular data value appears in the data set. Let's look at this example. We have a what? We have a study recorded the age of 20 patients. So this is the record from here to here. So you may ask to present this data in what? In tabular form, in frequency distribution formats. So all you need to do, you now take the values, you arrange them in ascending order. Okay, that is the first thing to do. You arrange them in ascending order. You take all 25, you start with them. Then if there is 30, you go with that. If there is 31, Babu, but we have 32, you go. Then you look at 35, if there is 35. So you go and arrange that. That is the easiest way that you can capture all the values. So in this our problem, we have 25 here. Okay, we have 25. Here is another 25. Here is another 25. You can see we have 25. So we have 4. This is how we arrive at this 4. Then we'll go for 30. Look at 30 here, 1. We have another 30 here, 2. We have another 30, that is 3. We have another 30, 4. We have another 30. So we have 5. So you can see that is how we also arrived at the other values and their respective frequency. So this is the first method of presentation of data is what? Is the tabular presentation. And the most common one and most powerful one is the frequency distribution table. Okay, you have the value, you have the distributions in terms of frequency. The second way of presentation of data is the graphical presentations. Okay, in the graphical presentations, graphs are visual presentation of data that can make complex information easier to interpret. The type of graph we use depends on the type of data. Is it, you see, is it qualitative, that is categorical, or quantitative, which is discrete, or numerical? So you can see it depends. You can't just take any graph and say, I'm going to present the data with it. You have to determine, is it categorical or is it numerical? Let's start with the first, bar chart. A bar chart uses rectangular, we're going to see the examples. A bar chart uses rectangular bars of varying height to present data. Okay, it is most suitable for qualitative or discrete data. You see, that is why I bolded it. It is very, very important to note this. Bar chart is more suitable for qualitative, that is categorical. Is it nominal or ordinal? How we are getting it? Then discrete data, not the continuous data. The bars can be oriented vertically or horizontally. Let's look at for this example. Though I have not drawn the bar chart, I'm sorry, please. But if you can see, the most important thing, you have blood group. And don't forget, blood group is a what? Categorical data. That is why we're even using it to a distance. We are going to plot the graph by ourselves. I will give you as an assignment. So this is the first one. Then the next one is the pie chart. A pie chart is a circular chart divided into slides, where each slide presents a proportion of the whole. It is used to show the relative size of different categories within a data set. The entire pie represents 100%. So in the case of pie chart, the first thing to do is to find the sectoral portion of each data. Sectoral portions. And how do you do that? You take the frequency of that, you would divide it by 100. That will give you the, you divide it by 100. So, sorry, by the total frequency and multiply by 100. That will give you the sectoral portions of each of these data in the data set. Then the next pie is also can go with the what is it called, categorical data. I'm going to show you all these things. Then the next graphical presentation is the histogram. It's similar to bar chart, but it's used for continuous quantitative data. You can see the difference. Where bar chart is used for what is it called, categorical or discrete data, histogram is only used for continuous quantitative data. Get to understand. The bars are adjacent to each other, indicating that the data is continuous. You are going to see in bar chart, the rectangular uh, 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 picture diagrams are separated, but in histogram they are adjacent. They are touching. One is touching the other. The width of each bar present the class interval, and the height present the frequency of the interval. So you can see this histogram is more suitable for what? For group data, for grouped data. You can see. So you can see 50 to 59. We have that. Then the next one is the line graph. A line graph displays data point connected by straight line segments. It is typically used to show trend over time or a continuous variable. The same thing with histogram is applied to continuous data. We are coming to see. So it's a just continuous line, but it may be up, it may be down, it may be zigzag, it may be a straight, like what you did in your secondary school. In your physics, you are asked to plot a graph, okay, with temperature, with time. So you see, it's going to give you a straight line graph. So this is what we are seeing. That graph is also a presentation of what data that you collected during the practical. So the same thing in the line. Then number E, box and whisker plots. Okay, box and whisker. A box and whisker plot or box plot is a standardized way of displaying the distribution of data based on a 5-number summary. So here we're using what? We're using the quartile. So you use the first quartile, Q1, the sub-medial quartile, third quartile, maximum. You know, we have only 4 quartile. That is 25%, 50%, 75%, and 100% of our data. And this is what the people are complaining. If you want to calculate the first quartile, is the total number of data set divided by 2. By 4. It will give you. Then the second quartile is going to be total. That is going to be what? It's going to be what is it called? A total data set divided by 2. The third quartile is going to be 3/4 of the total data set. This is how to calculate the quartile. So we are also coming to see all these diagrams. So I don't know if you, this is all about data presentations. So here is an assignment which you are going to go and do it on your own. You are not submitting this one. I will place it there now. So this one you can go and try. A researcher collected a data on number of hours 30 students study for an exams. So we have the data. So you are asked to create a frequency distribution table. So you now do what I have said earlier on, then draw a bar chart to present the data. Why are we not using histogram? Because we are using what? Discrete values. Then draw the bar chart showing the percentage of students in all lessons. Tomorrow we are going to do the calculation for this one. But for the meantime, if you have any questions, you can ask. You unmute yourself, and then you ask your questions. Then we move to the next thing. I'm going to show you material that I may likely forward it to you, inshallah. So the floor is open for you to ask questions.
Good evening, sir.
Good evening.
It's about this quartiles. You said it's divided into 4, that we have 4 part of them. I only got the 75, the 50, and 75. Please, what are the other ones?
When we say quartile, we have the first quartile,
Okay.
which is the n/4. Okay, n/4 is our what's it called? The first quartile. Then the second quartile is n/2. That is 50% of the data, number of data that are here. You know, when you calculated the number, so you go there and count. Okay, you count the value that is given to you. Let's say, for example, the example that test will start. We have been given what? We are given 5, 7, 5, 7, what? 8, 9, and 10. So we have 5. So if somebody asks you, okay, what is the first quartile of this one? So you cannot say is what? You add everything that is there, you divide it by 4. We have 40, 30, 30, 39. 39 divided by 4, you get what? 18 point something. That 18 point something is the first quartile.
Okay.
So if you are asked to calculate the second quartile, you divide it by 2. That 39 divided by 2 is going to be what? Oh, sorry, the first one is going to be 9 point something. The second quartile is going to be 18 point something. Then the third quartile, you find that is going to be what? Around 29 point something. That is how to calculate it.
So please, the first quartile will be divided by what, sir? The third one.
See, if you didn't have a value, we'll continue blowing grammar. Get
okay, sir.
Then you forward the questions. Is the question that we use to what is it called? We used to cite the example, because when we continue just talking, we will not have the real aspect that we are looking for. Get a question that have values, then we use to cite the example with it. So, any other questions?
Thank you, sir.
Good evening, sir.
Any other questions?
Good evening, sir. Sir, in the quiz, there was also a question about percentile, and I don't think you have taught us about percentile.
It's the same quartile. When we say quarter, what is quarter?
Quarter is half.
Quarter?
One quarter. Quarter is 1/4.
Percentile is what? It's based on percentage over 100.
Yes, sir.
So what is the? So do you need to be only asking you quartile? It's just a way of just manipulating you, telling you there is so many ways that you can be asked. So it's the same thing. It's the same thing with the percentile you are talking about. Yeah, we are just talking about. Hey, see, let's come back to, let's not go and digress and go back to something else. Let's look at our data presentation. Ask a question that has to do what we have just discussed. So in this, you can see I prefer this one also to at least give details of what we have just discussed. You can see it. Okay. So you can see I revised the types of data first. Okay. We have the categorical data, and under categorical data, we have the nominal, we have the ordinal, which you have already known. Then we have the discrete, the numerical data, that is quantitative. We have the discrete, we have the continuous. So here we have the various methods for data presentation. The textual presentations, which I've already said, which involve presenting data in written form, that so number of people came to our hospital at 10 p.m. to 10 p.m. So you see, you are putting data, but in textual presentations. You are putting data in textual presentations. Okay. And this is used for small data sets. You can see I just use time and number of people that enter. Where you have so many data, large volume of data, you cannot use textual presentations. Okay, example, the study included 10 patients, 100 patients, of whom 60% were female, 40% were male. The mean age of the patients was 45.5 years. So you see, this you are presenting data, but in textual presentations, in textual. This is one area I have not taught in the earlier presentations. Now, number 2 method is the tabular, which I've already explained, involving organizing data into table consisting analysis of data. The key component of the table is what? Is we have 1, the table, number, and title. You must give the table a title. But yes, you can say that the table of what? Table 1. Now you put a column. I will now say number of patients visiting so clinic. You must give it a title. You give it the, if you didn't do that, they will mark you wrong. So when you are doing tabular presentations, you must ensure you put table number 1, table number 2, and the table number is normally put what? Inserted at the top, at the left top here. Look at it. This is where you are going to put your table. You say table 1. Okay, you put column. You now give the title. That is how to do it. Then a table must have column headings and row levels. What is the column headings? Age group in years. You can see it. Number of patients is here. That these are what we call the column headings for the 2 columns. Then row levels. So you can see our row levels here. Then the body of the table containing the data and the source of data. If you are not the one that did the practical or you collected the data, then you must insert the source of the data at the bottom of the table, somewhere around here. You write source, you put column, then you write the source where you got the data. The second method is, the third method is what? Is graphical presentations, which I've already said. It involves using visual aid to present data, which makes data more appealing and easier to understand. And the most common types are, as you said, we have the bar chart, we have the histogram, we have the pie chart, we have the line graph, we have the scatter plot, and then we have the box plot. The only addition here is a scatter plot. The bar chart used to compare categorical data. Please get to understand this. Categorical data or discrete data. The histogram is used to display the distribution of what? Numerical data. We know numerical data is the discrete data as well as what? Continuous data. Then the pie chart is used for categorical what? Data. It's used to show the proportion of each category in relation to the whole. The line used to show trend over time, which I've already explained. The scatter plot used to show relationship between numerical variables. Let's look at the bar chart. So you can see a bar chart is I'm just summarizing, please. I know this is no DLC Biostatistics Com 201. You never see data presentation. That is why you see I'm very, very interested in this aspect of study. A bar chart is graphical presentation of categorical data using rectangular bars I've already explained. So look at the examples here, okay? The example say a study was conducted to compare the number of patients with different types of disease in a hospital. So the first thing in this question is we are saying different types of disease. These different types of disease, is it categorical data or is numerical data? It's a categorical. And even in the categorical, is it nominal or ordinal? It's a nominal because we are just dealing with type. There is no ranking. We are talking of types of disease. So there is no any ranking. So we are confidently seeing that the best way to present this data is using the bar chart. And this is what happens. So we have to create a bar chart. And this is what we should have in our bar chart. Draw the x-axis and the y-axis. Level the x-axis, disease. Because whatever comes in the first column is what is constitute our horizontal axis. That is x-axis. Whatever comes on the what? On the left column, on the right column, that is what is going to present our y-axis, the number of patients. Then you draw a bar. We are going to do this one practically by tomorrow, inshallah. Or I think I should give you an assignment. Everybody should go and draw it. And that is an assignment. I will forward this lecture note to in your WhatsApp group. So histogram, the same thing. Okay, histogram is the same thing. Okay, so you can see this is the method. The first thing to do, determine the range of data. The highest minus the what? The smallest. What is the highest value? Is 82. What is the smallest value? 37. That's 45. So we have 37. So divide the range into a suitable number of what? Bins. 7 to 5. In each of these, then you calculate the bins interval. Look at what we mean by the bins. Okay, define the bin intervals. Somebody will ask me, where do you got 7.5? Look at it. We have the interval of 737. And we want only 5 bins. What do you mean by 5 bins? Is what? 5 rectangular blocks. So I divided 37 by 5, and that was where I got 7.4. Something. So I approximated it to 7.5. So that is the 7.5 ones you are seeing here. So my first bin is going to be 45. Then the upper, this is the lower. Then the upper of that bin is going to be 45 plus 7.5. Then that's where I got a bin of what? 45 and 52.5. Then the next class is going to be 52.5 plus 7.5. Then we are going to have 60. 60. So this is how we arrive at these values that you are seeing here. So if I come to draw the table, the histogram, I will show you. I have to do it. So the next thing, you count the frequency of data point in each bin. Then you draw. Look at how you draw. The first X and Y axis, level, draw the bar, each bin with a height corresponding to the frequency. Like in this case, what is the frequency for the first bin? That is, we are talking about 45 to 52.5. Let's see. We have 1. We have 2. Where again? We have 3. Where? We have 4. We have 5. We have 5. We have 6. We have 6. So we have 6. Then you now draw your rectangle to what? Equivalent of 6. You determine on the x-axis the value of 6, then you draw a rectangle up to that particular one. Okay? Then you now take the next bin. Look at it. I'm taking this one. This is what I'm using. 52.5 to 60. 52.5 to 60. I have 1. I have 2. I have 2. I have 3. I have 3. I have 4. I have 4. I have 5. I have 6. So you can see. Okay, you can see. So that is how to draw your bins. Then look at this one also. Okay, pie chart. In pie chart, all you need to do, you see these are what? 60 plus 50, that is 110, 110 plus 30 is 140, 140 plus 60, that is 200. This is where I got my 200. Then for me to get the degree or the percentage, I will now say 60 divided by 200 times 100. I got 30, 25, 15, 30. Now, I want to find the degree, that is the sectorial portion of each. I will now say 30 over 360 times 100. That is, it's going to give you 108 degrees. So if I come to draw, I will take 108 degree and say this is the portion of A in the pie chart. Then for type block group B, I got 19. AB, then that is how, when you add these values, they must give you 360. Let's see. 108 plus 90, that is 198. 198 plus what? Plus 54 is going to be 200 and what? Nobody is going to give me the value? Okay, let's go on. Just
252. I'm 52, sir.
So then you add 102. To give you what? 360.
Yes.
That is 360. That is so you can see that is you now used your compass and protractor and you draw the pie chart. You calculate, you measure 108 for A, you measure 90, 50, and so on and so forth. So you're also going to draw this pie chart. This time around, you are not going to submit the assignment in the form of PDF. You do it on a sheet of paper. You use scanner. No, don't take picture. I don't want picture. You take either Adobe scanner and you scan. That Adobe scanner will convert your drawings to PDF. So you just submit it. Don't take pictures. Pictures sometimes, and just take your phone. We have what is called Adobe scanner or any other scanner. You scan your assignment because you are going to draw these ones. When you draw them, then you scan. Then you forward it to our LMS assignment. I'm going to put the assignment. So this time around, as I said, we're going to have 2 assignments. We have for measure of variability and then for data presentation so that we are done with descriptive statistics. Then the next one is the line. Okay, I've already explained the term of line. So also the same thing, you can see. So you can see the same way. Because line is dealing with what? Data with respect to time. In 2050, you have this one, you have this one, 2026. So you have to create a line graph to present this data. So the same way that you're going to do for, let me show you, then this is for scatter, okay, and then this is for plot. I know some people are eager to see the different types of uh, 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 the the graphs. Let me see if I can get, yes. So you can see, okay, you can see. Let us see the different types of this data graphs. This is a table. You see, this is an example of table. Are you seeing it? Are you seeing it?
Yes, sir.
Yes.
Yes.
See,
Yes,
you
sir.
can see, go, look at, yeah, well, look at it too. Look, you see, I say you must give the table a number. Look at the number. If you are asked to present data in tabular form, if you didn't put this table number 0, every table must have its number. The table number of this one is 7.1. And then this is the table title, distribution of students according to course and economic status. You must give every table number and title, and it's always at the top of the table. Don't go and put it at the bottom. Fine. We say a table must have what? Must have rows and columns. So this, look at how many columns do you have? 1, 2, 3, 5. We have 5 columns. How many rows do we have? 1, 2, 3, 4. Then we say that a row must have row title. This is the title: science, art, commerce, and total. We said, sorry, a column must have a title. A row must have a level. This is the level: rich, middle class, poor, total. So these ones, we call them level. This is a common example of tabular, what? Tabular presentation of data. Let's look at the next one. The next one, bar chart. So you can see, this is the bar chart. You can see, this is a bar chart. You can see, this is ABC. ABC is the x-axis. Then we have the y-axis. What you see, this is, I told you, anything that comes on the first column will be our x-axis. Second column will be our y-axis. You can see, that is one. Then number 2, this is at the rectangular blocks. You see, we have a rectangular block here, we have one here, we have 4C here. And one important thing to note is they are all separated. They are not touching. You can see they have interval. And each is drawn based on its what? Frequency. This is the frequency. A has a frequency of 8,000. So look at, they draw it to 80. Then the next one is 10. Look at it. It's here. And then the next one is C, which is 40. So this is typical. Also, your bar chart must have what? Figure. This time around is not table number, it's figure. You can see, and it's written at the bottom. Look at figure 7.1. And it must have a title: car registered in states. If you didn't do that, I'll mark you 0 in your assignment. So you can see, okay? So this is a simplest bar chart that you can have. We have a compound bar chart. Okay, sorry. This is, I told you earlier on that you can present the bar chart either horizontally or vertically. So this is the vertical presentation. And then this one is the horizontal presentation. So you can see the rectangular blocks are laid on what? On horizontal axis. Whichever one you did is accepted and is going to be marked correct. Okay. So this is another different one. That is, if you have more than one, you see, you have two on the what? On the x-axis. The y-axis is always here. Okay. 20, sorry, yeah, our x-axis is here. So you can see. So you can see here our x-axis. So why do you have these two? Because for every 1 year, we have two components. You have 2955, 2523. You can see them. For this one, you can see them. So we can have this kind of bar chart as well. But the most important, watch out, they didn't touch any. This one, the black and the white, is because they are belonging to the same year. That is why you see they are matching. So in that case, it's showing us it's a continuous data because they are touching. Likewise, if you have three, okay, look at for three. Look at, you can see for three. So this is this one also is a bar chart, but nobody is going to ask you about this. Then the pie chart. Look at the pie chart. Okay, first you have to do the calculation. I have already informed you. Okay, you have to do the calculation. Look at it. You are given this data, and these are the expenditure, and the total expenditure is 600. Like what we did 200. So you can see 360 divided by what? Divided by what is it called? 600. We got 60. Now we now say 60 over 100 times 360 to get the degree. We got 216. You can see it here. The same thing here. 108 over total is 18. Then 18 over 100 times 360 will give you the angle. Okay, this is very important. You have to do these calculations to get the percentage, then convert the percentage to degree by dividing the percentage by 100 and multiply it by 360. Then you get the angle. What are we going to do after getting the angle? Then you see it here. This is the pie chart. For food is from here to here, which is 60. And don't forget, we got the angle there is what? Is 216. And that's why it has the largest share. You can see. So you can see if you measure from here down here, you got 216. Okay. Then this one, this one, this one. You can see this one. That is miscellaneous. Miscellaneous is having the lowest angle, which is 3.6. And that is why you see it's very, very small. So this is for pie chart. Then the next one is the timeline series graph. That is time. I told you is dealing with time and what? Time for line graph. So you can see this is the line. You can see. You can see it. It moves. So from A to B, you can see just what you plot. Okay, you look at the values. You have this year, this year, this year, this. So we plot our x-axis is the years. Look at it here. You have this. Then we have the productions. So all you need to do, the first year, you now dot. The second year, you dot. The next one, you dot. The next, then you now come and join what? You join the lines. Okay, you join the lines. So this is a line graph presentations. Then the next one, this is another format, but nobody is going to ask you this one. The histograph. So you can see the histograph. You can see the histograph. And don't forget, we say histograph is for continuous data. So you can see there is no space between the blocks. You can see, unlike the case of bar chart, the bar chart is having separation between one block to the next one. But here, this one, but they have almost the same method of approach in drawing them. So, but the major difference is this one, the blocks touches, they are adjacent. Okay, they are adjacent. So this is histogram. Then this is another histogram. Then you see, this is what is called the frequency polygon. Nobody is going to highlight you on this particular, unless when you see a question on it. So these are the various, these are the various graphs that we have, which you can present our data. So I hope they are very clear. They are well understood, and I believe you are going to do justice to our assignments that you are going to start working right from today, because I'm going to place it immediately after this class. I'm going to place the data to you to use. You see, the other time, people, when I do some manipulations, when there was an issue with the assignment, some people fabricated their values. And how can you fabricate a value for me and you solve and then you give me to mark? Why can't you mark your things? So when I realized people are complaining, I tested the corrected version. And still some people are asking, are they going to do it? Yes, of course. Because the other one you did is your own, because you are the one that give yourself the data. How can you fabricate your data and forward it to me to mark? It's not possible. So you have to do it. That is why I didn't even answer. Because this is, I don't expect this kind of question to come. What you did earlier on is wrong, and the correct one has what? Tested. Then you use it and proceed. You know, your problem, you don't want to read or understand instruction, and secondly, you don't want to follow the instruction, even when you understood the instruction. That's our major problem. Because the way and the manner some of us are asking questions, it shows that they are not reading the instruction, or they read the instruction, but they don't want to obey the instructions. You are asked, do this, just do and leave the rest. That is all. Don't do this, don't do it. That is all. You operate a very simple life, but you want to create a problem for yourself. Please, you have 3 minutes to ask questions. If you have any questions regarding what we have discussed today, please head and ask.
Please, sir.
Good evening.
Good evening, sir. Please, can you, before you give us the assignment, or can you help us solve one of them at least? And number 2, are we going to be allowed
I have
to
already solved. No, wait. Let me answer one by one. I have already answered. I look, even from these examples, you can see, we can see from this example here. Look at the solution. Look at the way you are going to do for what? Pie chart. You have been given the expenditure, you have given the data. These are the data. The first thing you convert to percentage. The percentage what? Degree. That's all. So you take each and every one. Even for the what are we also given? For bar chart, we solved. We are given this assignment, we have been given what? I don't want to blow too much grammar up to this. But the most important thing is we have been given a data set. Look at the data. And we're asked to plot the graph. I say everything here is going to be our x-axis. Everything here is going to be our axis. Then we'll draw our rectangular what? Proportional to the frequency we have here. That is all. So I've already solved one. So all you need to do is to go and read. You need to read. You need to research. We don't have all the leisure of time to give you everything that you need here. But that is why we're giving you assignments. And that is why we're giving you, what is it called? Priest. So that you go and research. Now that you know how to read more, how to construct bar chart, how to construct pie chart, histogram, line graph, box plot. So you go. And all these textbooks are there in our LMS. You open them, you read, understand before you even start approaching the assignment. Like this one, you're going to do it your hand. Because let me be frank with you. Some of you are still doing assignment with AI and forwarding. They will see 0 in their assignment. I'm telling you, every day I use a variety of AI. So if I see one, I will know. Nobody is saying you should not use AI, but you should do it responsibly. When AI gave you, the AI is just an assistant. It will just assisting you to do the work. It's like when you want to cook, you're using knife. Knife is a what? It's just assisting you, facilitating in cutting. Instead of using your hand to cut, you're using knife. The same way with AI. AI are not there to do the work. Who is doing the cutting? Is the knife? It's you. But you're using a tool. To what? To ease in the work, to facilitate it, to what? To speed up the process of the cutting. Instead of you to use your hand, you cut and cut, which there is a high probability of what? Injuring yourself. Then you have a tool. The same thing with AI. It's like you are driving a car. Who is driving the car? It's you. But you have a what? Well, okay, let me not use that example. If a mechanic, you took your car to automobile technicians, you will see him with spanner, screwdriver, chisel, you will see him with hammer. All these ones are what? Are tools. Instead of him to use his hand, he's using this tool to what? To do the work efficiently and effectively and to ensure safety. I want the AI. So by the time you just go and give AI assignment, do it for me. That is me, not the one that is doing. So how am I going to give AI marks? I will never give AI marks. I give individuals. I give student marks, not AI. So if I see you now forwarding AI assignment direct to me, I will give you 0 because I cannot mark a ghost work. So please, but what I'm saying in essence, we can use our AI. Okay, you can go to your ChatGPT now. You can go to your Meta AI. Briefly explain bar chart. Teach me how to construct bar chart. What is the difference between bar chart, pie chart, and histogram? It will tell you. What kind of category of data am I going to use for bar chart? What kind of data am I going to use for histogram? How is line graph different from box plots? ChatGPT will give you. You are learning. Then you use that particular knowledge that you acquired there, and then go and do the assignments. Maybe you don't have time to go to and read the textbooks. So you go to your ChatGPT, you go to your Gemini, you go to your Cloudy, you go to your Copilot, you go to so many tools, AI tools, AI agents. They will now guide you. Then you use the knowledge you acquire from them, then you go and do the assignments. If you didn't do that, you will be immersed. Do you know when you are going to find yourself in a very difficult situation and you never forget, and you never forget yourself. It's during the exams. Nobody is going to allow AI to do it for you. Are you going to have fun and give the AI the questions to do it for you? That is where you are getting it wrong. That's why you are getting it wrong. Now that the assignment is going to be given, you don't know how to draw pie chart. Ask ChatGPT to teach you. With the knowledge you have, Mr. ChatGPT, guide me on how to construct a pie chart. Take me through step by step on construction of pie or bar line chart. Highlight the differences between bar chart, pie chart, histogram, line chart for me. When it give you the response, okay, give me, okay, cite or draft or prefer an examples, a soft example on histogram for biostatistics students. This is how to go about it. You get abundance of knowledge, but you not just go and put everything garbage in, garbage out. You're not assisting yourself. Any other questions? Any question?
Thank you, sir.
You're welcome. So please try to do that. If you have an issue, then we'll discuss it at our platform. I can see a lot of people have gone. Some people have not put down the attendance. Please, we are marking the attendance. You will not see the effect and the consequence is when the result for assignments start coming out. People will start saying, shouting, I was there, I was there, I was not that, I was not that. Please, let's not do that. I'm thinking of organizing a class, a lecture for you, AI for students. That is how to utilize AI to further and understand and to apply them responsibly and ethically in the course of your studies, not only in biostatistics, but also in other courses, because AI is there to make us excel, not only to succeed, to excel, because we have been succeeding. But when you use AI, you'll be excelling. Okay, so we are going to organize that, but it's not going to only for this class. It's for all my classes that I'm taking. And we are also going to, if you have anybody that want to join, you can share the link with him. We're hoping by next week, we're going to organize that online. But it's going to be under my directorate, my center, that is Career Service and Polytechnic Advancement Center, New Bomali Polytechnic Zaria. So when you see the link, you're free to join. You will learn a lot. It will guide you. It will expose you to how to use AI responsibly and ethically, and with the latest guidelines, rules and regulations governing application and the uses of AI. But nobody is saying we should not use AI. Let's use AI responsibly and ethically. I wish you all the best. To meet tomorrow by 4:30 to go into the second phase of the last, that is, we are starting with inferential statistics tomorrow, inshallah. Thank you very much.